All right, folks, howdy. Today, we are going to be taking a look at CNC, more specifically G-code, and how G-code relates to the Cartesian coordinates and how we can produce G-code on or within our programs and how we can actually speak to these machines. So the first thing we need to review is if we take a look at our quadrants with our Cartesian coordinates, you should all be quite familiar with this. All right. In math classes, you should have reviewed the fact that there are, in fact, 4 quadrants within the Cartesian coordinate. We have quadrant 1, 2, 3, and 4. For the majority, if not all of our work, we're going to be working within quadrant 1, okay, which is positive on the y value as well as positive on the x value, okay? We will run into some negatives on this machine that you will see, but those negatives will always be set about an origin that can be positioned. So in this particular case, the origin is positioned directly in the center of our quadrants, where with this machine, what you'll find in videos a little later is that we can actually move the origin and place the origin in different locations. Okay? So, Cartesian coordinates, G-code, how we communicate with the machine. If you take a look at this specific machine, on this readout, when you come to work with this machine, you will find that there is both an x, a y, and a z value. All right? Those values all speak to our Cartesian coordinates. So we look back to our Cartesian coordinate, you'll find that we have values in both the x direction and the y direction. If you take a look at this machine, I can move this machine in both the x direction, which is along this axis, this is our x direction on this machine, and our y direction, which is along that axis. All right? So this machine has the capability of taking material that is 48 inches in width, which would be our x direction, and 96 inches, which is roughly, this will take roughly 8 feet in length. Okay, so if I were to come over and take a look at this position right here, and if I were to call that position zero, comma, 0. All right, so if you take a look at my x value as well as my y value on my computer at this point, they both read 0, 0. What that's telling me is my x direction is at 0, my y direction is at 0. All right, CNC machines only read off the Cartesian coordinate in the sense that this machine is not a smart machine. This machine is simply reading values of x, y, and z and doing it at simultaneously so it knows whether to ramp, all right, or to make straight moves. And what I mean by that is if you take a look at two simple components. On this component, you'll see that it's very two-dimensional in nature, all right? It has both x, y, and then it just has simple z's that take it down, all right? So my x direction would be running this way, my y direction would run this way, all easy values. My z direction would plunge negatively, but they're all very linear. When you look at this part, you can see that this part has different angles, lines, and ramps built into it. So what that means is this machine is also capable of not just running x, y, and z independently, but it can also run those dimensions at the same time to create this ramp effect. In effect, we could possibly create a half sphere with this machine based on our x, y, and z values all being changed at the same time or simultaneously. So the most simplistic way to look at how these machines read the G-code is to take a simple yardstick, ruler, meter stick, whatever it might be, and if you were to lay this on our line here, you can think about rulers going both in the x direction, the y direction, and the z direction. Now, what that means is this machine, if I'm starting at 0, 0, 0, if I place my yardstick at 0, 0, 0, if I were to tell this machine, I need you to move to x0, y20, it's going to move up my ruler to 20 inches and stop. So if I tell this machine x0, y20 and set it there, it will move to 20 and stop. So if I take a look at my ruler right now, I'm reading directly at 20. That's the basis of the CNC machine, okay? The fact that it can read a specific measurement and move to that point. Now what's very interesting is the fact of how precise this can read. If you take a look, my Y value right now is 20.0000, okay? In other words, that's capable of reading to the 10,000th of an inch, all right? So quite often when we're machining a part or creating a part, we're not reading to just 20 inches, but perhaps we'd be going to a precise measurement like 20.253 or something to the 1,000th of an inch like that measurement. If you were to think about these specific dimensions, if you could create a part driven off those dimensions in a series of code and send it to the machine and tell the machine when to cut, when not to cut, based on those series of dimensions, you would create the basis of G-code. All right? So what we're going to study is how we can create G-code to input to this machine so that I don't have to come over here and physically type those dimensions in. I could do that dimensioning at a different computer, enter those dimensions, so that when I come to this machine I can actually input those dimensions. It will run those dimensions at a quicker rate and execute it much, much faster to those high precision levels. All right?